All right, folks, welcome to Support Vectors. A warm welcome. It's nice to see all of you come here on this in California. It's a really beautiful, sunny morning. So if you're not in California, might be a good time to think of moving to California, right? We have perfect weather. And the very fact that you're willing to give up such a beautiful day outside and be here speaks to the fact that you are quite interested in this subject. It's a beautiful subject, this subject that we are going into, machine learning or data science. So besides just welcoming you to Support Vectors, I would like to also actually, as a person, as a practitioner of this field, like to warmly welcome you to the subject itself. And it would be my honor, it would be my pleasure to take you through a journey in this subject. As you will find, it is it's a very fascinating subject if you think of it as a zoo, and if you just look through the wonder of a child's eyes, a child's mind, you will see that this land, this zoo, is filled with exotic animals, just wonderful animals, very, very things that will thrill you, things that will surprise you, right? Things that will make you wonder, how in the world did somebody think of this? Right? This is the culmination, this field, machine learning, is the culmination of not something that is recent, but long thinking, massive amounts. Some of the best brains in the world are today devoted to thinking about this field. Every day, they are like practically every day. It wouldn't be an exaggeration to say that every day there is some or the other progress made. And you can see in the research community, and I'll introduce you to those preprint place, archive, and so forth. You'll see papers are appearing every single day. And these papers are not, some of these papers are quite interesting. It is hard to keep up. For the last, I would say, 30 years, leaving aside my undergraduate education, for 30 years, in one form or the other, being involved with numerical computations and so on and so forth. And very actively doing this for at least the last 20 years. And still I can say, like, that I suppose, when was it, 2001 to now is 21 years. Okay, that's a long time when I'm actively doing data mining, machine learning, artificial intelligence, or what they're saying. It's still, if I look at this field, I still have that sense that I am just getting started. It's an amazing field, and the more you know, the more you feel, well, there is so much more to know, right? So with that sense, let us continue into the subject. Now, before I go into that, I will set a few ground rules for the course, or just introduce you to the course. So this course will be, is my screen shared? Yes.
Yes.
So some basic ground rules. We will have 6 Saturdays, the course. Oh, no, black would be better. Let's take a darker color. Course, it will have 6 weeks, 6 Saturday sessions, Saturday full day sessions, full day sessions. This is what it is. But that is not the end. That is the interactive part of it. If you want to take this course seriously, you will have to devote at least 1 hour a day for the remaining days. Right? So you can decide how to give 6 more hours to this course. Right? You could give all 6 hours on Sunday and be done with it, and then go back to your job and not worry about it. Or you can pace yourself, whichever way you do, but expect to give a plus 6 hours of self-study and lab work. You will get homeworks. So this is the 6 week, 6 Saturday full. These are the lecture sessions. Now, every day, we will have a breakdown. Mornings, or California mornings rather, mornings would be the lecture sessions, lecture theory sessions, and afternoons would be the lab. Are we together? We'll practice what we learn. Right? This is how it will go. Now, there are 6 days, which means that we are going to do at least 6 core topics. Now, what will happen is, besides this formal 6 days, which I consider the core minimum, if you want to learn about this, this is the core minimum. Then there's the optional. This is it. There are optional stuff. Now, this optional stuff, I mean, you could say that the 30% of the course or 40% of the course is actually in the optional category. Why is that? This workshop is designed for very busy professionals. Based on how very busy you are, you may or may not be able to do the optional parts, right? And but you must do the core minimum, otherwise you won't gain things from it. Put in your 6 hours of self-study and lab, put in the 8 hours here, so 14 hours of effort a day. If you think about it, that's a substantive amount of an effort that you are putting into this course. So do please gear up for hard work. This, you're entering a fascinating field, but you won't get much out of it unless you put a lot of involvement from your side. It is my hope and my responsibility that I will get you excited about this wonderful, wonderful subject so that it comes natural for you to put in those 14 hours total, 8 hours here and 6 hours on your own. Right? But if you have further motivation uh, and if you have time, there is more that we do. In the optional category, we have you will have paper readings. This paper reading could be either good blogs, and these are guided paper readings, and I'll talk about that. But good blogs, it's occasionally classic research papers, classic research papers. There will be projects to do, group projects to do as a group. Some of you may want to do, and presentations. So let me talk a little bit about these. See, this field is very fast moving, right? And if you see something in the book, quite likely it is either foundational, it needs to be there, or it is already obsolete, right? It's that fast moving, especially at the cutting edge. By the time something shows up in print, in books, you can almost, you should suspect that it has already been superseded by something else. The subject moves that fast, but the foundations don't change. Fortunately, this first course focuses on the foundation. Nonetheless, I want to get you into the habit of reading what is happening at the state of the art. The other thing, the other practice that I learned in research was, when you learn something, go back and read the original paper. So when you want to learn, for example, in physics mechanics, it is all right to read a textbook on mechanics. It may be moderately interesting, but it is far more interesting to go back and read Newton's original work and see what he was thinking. Right. So the same thing, when you read relativity, for example, it's one thing to read it in books, another to go and read, for example, Einstein's original paper. And paradoxically, sometimes the original papers are far more clear and direct and interesting than the textbooks. Right? So we will read some classic papers in this field. That is purely optional. I typically do it on Sunday evenings, time permitting. Right? If I'm busy, I may skip it, but Sunday evenings, 8 p.m. In India, 8:30 in the morning, Monday morning, is the paper reading. Then we have projects. These projects are group projects. Depending upon how motivated you are, I would strongly suggest you do the projects. And they are designed to invoke interest in the field. If you can give extra time, you'll do that. It will take you through the whole life cycle of the field. A data scientist, science is about, measure, right? Observe, measure, learn, and then you repeat from that. You learn something and you repeat, right? You ask a question, you go observe things, you measure things, and then you learn. Now, the subject of machine learning, the textbooks often very narrowly look at, they assume that the data is there, it seems to have magically appeared, or some minions have produced the data for you, and you just do the intellectual part of learning. It doesn't work like that. It is a very integrated field. How you observe data, how do you measure data, what data you bring overwhelmingly influences the kinds of learning or theories that you can build around the data. Therefore, we'll go through the entire journey. You will walk out and from the environment, learn to pick data, create your own measurements, and with those measurements, then apply machine learning techniques to them, and then build models, and then come to some understanding that you did not have before. You'll discover something. So you will go through the entire discovery process. So that is what projects are. Now, projects, by their very nature, are open-ended in how much time they can consume. Each project can consume about 10 hours of time. How many projects you do is totally up to you. I would encourage you to do at least 2 projects in the 6 weeks, 3 projects, 3 weeks per project. You will have a lot of fun. It will excite you. It will teach you something much more than just the sessions here. So do that. And finally, if you do the projects, or if you read an interesting paper and you want to present, we have we are starting the weekly presentation series. Now, those of you who are physically here at Support Vectors, you are aware that we have an excellent lounge at the back, which has a theater grade laser projector and a theater grade screen and a lounge to sit in. Some of you have made presentations in the lounge. So it is total fun to sit with your peers and present to them what you found, something interesting. And we take it in the spirit of this I found. Now, what you found could be some analysis you did, the projects that you did, or it could be some interesting blog or paper you read. And you may want to present it on your own. And if you do present it, we give you full support. This is a safe zone, guys. Now, we all work for companies, right? We all have, well, good bosses, kind bosses, or terrible bosses like me, right? And some of my teammates are here in this particular batch. So, well, when we are with our workplace in engineering, there's an expectation that we appear smart and capable, and we seem to know everything. So the basic rule of an engineer is, can you do this? The answer is yes, even if you have no idea what it is. Absolutely no idea. Can you create a nuclear fusion reactor? Of course, right? In 6 months, of course. And then you scratch your head, how did I do that later on, right? So, well, that's what we do in our workplace. It is a survival mechanism, right? Because this field, there's a lot of braggadocio, there's a lot of overwhelming confidence that's projected. But we are not in a workplace. This is a safe zone. This is a place of learning, which means that we take our guards down. We are not here to judge each other. We are here to show what we know and what we don't know and help each other. Learning is a social activity, and I would like to dwell upon it because you will see that my learning methodology is somewhat different from what you're used to. You may pose this question: why would you be here? Why would I not take a course, let's say in Coursera or Udemy, or just YouTube has abundance of excellent videos. Why in the world would you come and sit in a classroom? And there, I would like to say a few words, and it would be the only time I would be saying this. See, I've spent 30 years now, both as a technologist, as a scientist, as a in the STEM field, right? Doing all of the science, engineering, math, and all of that. That is one aspect of it. For 30 years, it turns out that I have also been teaching. The reason I teach is partly because I feel to share is a duty. We should share what we learn. If you love knowledge, you need to share it. Right? So for 30 years, I've been teaching. And as you teach, you learn a lot about what helps people learn, literally. Right? How is it that people actually learn something? and you get into the theories of education. Education, it turns out, is a field in its own right. People do Bachelor of Education, Master of Education, and so on and so forth. And of course, teachers, etc., are supposed to take that. So you get involved in that. In that subject, there's a lot that is understood. But one of the first things that you understand, a few key elements that I would mention that is important are: mind is a leaky bucket. Deliberately, one of the singular powers of the human mind is that it can forget. It's a forgetting machine more than anything else. And it is necessary. It distills from the experiences all that it needs to preserve, a small amount. And it sort of sieves through and gradually forgets the rest of it. Right? It is called the forgetting curve, that was discovered, I believe, in either 1811 or thereabouts, 200 years ago, more than 200 years ago. The forgetting curve essentially says that in 30 days, you would have forgotten most of what you learn. In 90 days, almost everything that you learn. Right? So any facts that you are taught, right, you would forget the facts. We don't remember the facts. Human mind is not meant to remember the facts. In fact, there is such a thing. I believe the word is eidetic memory or something. There are people who have never forgotten anything in their lives. It's actually a disease. And from what I hear, they live pretty traumatic lives simply because they can never forget anything. Right? So human mind forgets, and that's a blessing. But it forgets facts. So to teach facts is not terribly relevant. If I were to teach you all the facts of machine learning, a couple of months later, you would not remember most of it. You folks have sat through a lot of courses in which you have gone through slide deck, marathon slide presentations. How many of you have been through lots of presentations with slide decks? Right? Almost all of you. How much of it? And I am sure that when you have slide decks, they dazzle you with the facts that they have, interesting facts. It looks, and there is a narrative through those interesting facts. You, after a few months, after you don't remember those facts. How many of you remember the slide decks fully, or even half of it? Right? You don't. Slide decks are meant to capture facts, and you forget them. So there is no point in learning from slide decks, right? Or learning from facts. Well, slide decks are not always facts. Sometimes they convey understanding. It depends upon how they are. But quite often they are facts, they're equations, they're numbers, they're code, and you forget all of that. But what is it that we don't forget? We don't forget two things, folks. Human mind, we are nurtured through stories. Ever since we were children, we have been building in our mind stories. As a person in the STEM field, as an engineer, and as a physicist within my engineering degrees, I grew up to believe that the world is made up of atoms, isn't it? From the Greek word atomos, indivisible. The fundamental element is the atom. Today we know that atoms too are made up of subatomic particles, the quarks, the this and the that. And I happen to have worked on literally particle physics, the subatomic stuff, and had a couple of papers there, research papers there, and so forth. But it's a very interesting thing. What is that made up of? We don't know. Even those things, those quarks, those things may be made up of other things, many layers smaller than that, orders of magnitude smaller than that. There are hypotheses about string theories. Now, what are those strings made up of? And there is no end. You can keep asking. Whatever somebody says, you can keep saying, what is that made up of? And that is a physical journey of exploration into nature. But there is a remarkable thought that people in the humanities have discovered. There's a famous saying by somebody, I forget, that struck me at some point that said, the world is made up of stories. Not of atoms, but of stories. And if you think about it, what does our mind do? It looks at certain events, certain phenomena in the external world, and immediately we start trying to say, oh, so for example, um, you notice that a person goes, you happen to notice, my neighbor happens to notice that I walk to Starbucks, right? Every day in the morning, right? One day I go, second day I go. You create a story that Asif tends to like coffee. He only prefers Starbucks coffee. He goes to Starbucks every day. Then you notice one day there was rain. And then you notice that Asif wasn't there going to Starbucks anymore. Your mind creates a narrative and understanding that when it rains, he doesn't go for coffee, isn't it? Are we together? So our so-called understanding of what is happening are actually stories that we build. Theories of physics, theories of biology, of science, all of science is actually a collection of stories that make sense. The difference between those stories and stories from fairy tales is one is grounded in data, right? One is substantiated by data, the other is not. Are we together? Right? So
Yes.
we need to take stories very seriously. And when we do this workshop, you will notice that I won't be using a slide deck, but I will be telling you a whole lot of stories. Right? The other thing, because stories is understanding, and understanding is what we carry with us for the rest of our life. All of you, or most of you, have been through calculus at some part of your life. If I were to ask you, let us ask a question. How many of you can tell me what is the integral of e to the minus sine square x dx? How many of you at this particular moment would give me even an approximation to what this answer could be? Right? You would not know that. While you would not know that, but if I were to tell you that, let's say that it is some sort of a curve, and this may not be this, if I give you some function and I give you, let's say a, b, and I say integral is actually whatever the function, integral is area under the curve. How many of you remember that integration is actually area under the curve, right? All of us remember. Now, what is the difference between A and B? A is understanding, it stays with us. B is something we learn to do through facts, through mechanical things we learn. This is this technique. If you use this technique, you can solve something like this, for example, isn't it? Right? So we forget techniques, we forget facts, but we remember understanding. So in this workshop, the way we'll learn machine learning will be a little bit different to the way that you're used to. We will learn it through, we'll focus on understanding rather than facts and techniques. But facts and techniques are important. Facts and techniques exist in textbooks. So we will supplement our lectures with a background reading or review reading after the sessions in textbooks, which you need to take seriously. Right? The textbook, and we'll walk in the afternoon through all the material. The textbook that you will use is a very interesting textbook. It sort of is the happy Goldilocks region between two extremes in machine learning. So the machine learning textbooks are written typically by two entirely different tribes of people with two entirely different cultures. One is a tribe of programmers to whom everything is code. Are we together? And these are people with computer science degrees or programming experience. When they write books on machine learning, they get the programming part very well. They emphasize the programming part. They are, let's just say, very inelegant and quite often wrong, or they don't clearly explain, or they leave a lot of gaps in understanding when they explain the foundational ideas of machine learning. On the other extreme is another tribe of people who tend to emphasize clarity and precision of thought. They're very good with the foundational ideas, but they tend to be way too mathematical. These are people typically from mathematics, applied mathematics background, or theoretical computer science background, right? So when they write textbooks, they tend to be filled with theorems, and uh, theorems are usually scary for for mere mortals like us, isn't it? We see one theorem and we immediately run to the hills, right? So then that is the other extreme. But somewhere in the happy medium are a few books which have both. They have rigor. They explain things rigorously, but nonetheless with simplicity, with lucidity, so that you understand them, and they are very close to practical applications. This is a relatively small group of books, and the one that we will standardize on this course is for the textbook is called Introduction to Statistical Learning, ISLR. That is typically written. If you go to a website called statlearning.org, I believe, you will come to this textbook. This textbook is freely available. You don't have to purchase it. The PDF is, and it's not illegal to download the PDF in all countries. The authors, by the way, the authors were two professors at Stanford and two of their graduate students who are now themselves professors. Introduction to Statistics. Now, the history of this book is the two professors at Stanford, Hastie and Tipshirani. These are obviously legendary professors. They wrote a book, Elements of Statistical Learning, which was a great classic. But this great classic needs you to be a graduate student to understand it. Right? They need you to be really good with a lot of foundations to understand it. Then, as more and more there was a need to understand machine learning, more people got interested and apply machine learning to different fields. There was an initiative to write a less mathematical version of the book, more accessible version of the book, without losing the rigor, without losing the elegant thoughts in it. And two of the graduate students, one is Witten and the other is, I forget the name. Okay, so two more students joined, and graduate students, and they wrote a book, which is the ISLR. It instantly became a classic. That book is in its second edition now. If you can afford to, get yourself the paper edition of the book. You will realize that if you stay in this field, you'll end up highlighting most of the pages in that book. That book is very well thought out. Every page is a gem in that book. I would strongly suggest that you purchase that book from Amazon or wherever it is that you go to purchase your books from, the physical copy of the book. You'll need it, right? So that will be a primary textbook. For the theory part, for the practical part, there are a couple of textbooks. One of them, you will need to know Python. So if you don't know Python, we will be giving you a session on Python today. The basics, the amount of Python that you need to do this course is fairly minimal. You don't need to know all the esoteric aspects of Python. You just need to know enough to do data science, because what you need is the data science libraries of Python, which are more important, which are specialized, which you will learn as we make progress with this course. NumPy, SciPy, other things you will learn. So that is that. The second thing would be another book which will deal with something called pandas, right? So in this community, there is a concept called data frame. Think of it as a spreadsheet. Think simple spreadsheet, rectangular form of data is the format with which most data scientists work for structured data, for tabular data. And those things, the word is data frame. In whichever language, whether it is R or Python or Julia, whatever it is, we talk about a data frame as a basic unit of data, right? So where each datum, the singular data is datum, each datum is a row in the data set, which is a rectangular form, right? Columns are the attributes of the data, right? So we'll learn about pandas. We will also learn about, we'll use extensively of quite a few machine learning libraries. They're excellent libraries that have been created, which makes life very easy for us. Right? You don't have to learn numerical computations and a lot of deep things that people had to in our generation. When I was much younger and doing numerical computations, we had to write code in Fortran. Fortunately, all that Fortran and C code numerical recipes in C. And those codes are there. But what people have done is, and they have created nice Python layers on top of it. So even though you do your code in in Python, in reality, you're calling those libraries that a different generation of people have created long ago. And or more recently, like for example, some of the leading libraries like, NumPy, SciPy, um, TensorFlow, PyTorch, underneath all of them are actually Fortran and C++, C++ libraries. Even recent libraries like PyTorch and TensorFlow are written in C++ because they're extraordinarily fast languages. Python is a very slow language. So you only pretend to code in Python. In reality, execution happens in a lower level, a high performance language. And machine learning, as algorithms go, are horrendously expensive computationally. Those of you who did computer science would remember the big O notation. A good algorithm is linear or sublinear. It runs in order n notation or log n or something like that, or the one if you're lucky. N log n is for sorting. If it is quadratic, n square, it begins to get bad, isn't it? Now in machine learning, most algorithms are far worse than that in computation speed, right? So it consumes a lot of computational power. You need as fast a language, as fast a library underneath it as possible. So those are that. So we'll have some textbooks to deal with that. So that is for the textbook. We'll introduce those. I'll show you pictures and so on and so forth. The details will follow, or maybe Kyle, you can walk everyone through those. The next aspect of this course, in part of mandatory, besides the lab and the lecture sessions, there are two more things which are mandatory. They are A, quizzes, B, and these are necessary, I would call it necessary homework. Do the quizzes, guys. At the sound of sounding, at the risk of sounding as though I'm advertising, I must say that the experience of past generations have been that if they did the quizzes, they have sailed through all machine learning interviews when they look for jobs, right? Generally, they come back and say any interview, even from the top places, feels very easy after they have reviewed through the quizzes. These quizzes we have taken pains to create these quizzes. And the way you do the quizzes, it gives you a reality check of how much you have understood, right? So you might not score so well in your first attempt, right? Or to do the quizzes, it will force you to go back and review the lectures and the labs, and you do the quizzes, you get it wrong, then you go review again a few days later. Don't do it immediately. Come back a few days later and redo the quiz. You'll do better. Then a few days later, you redo the quiz. Don't do it immediately, because now you have just picked up the right answer and you'll remember it. But the point is to keep coming back to it. The word for it is spaced repetition in the theory of education. We know that learning takes place through spaced repetition. Right? You need to come back to the same material over and over again, but there has to be a time gap between the repetitions. If you don't give a time gap, you'll forget. But the more you repeat with time gaps, the more you retain. That's how you fight the forgetting curve. Do that. Homeworks are essential part of it, because unless you do the homework, you wouldn't know that you really know, right? Practice. This is practice. And lastly, there is a C part. There will be a social discovery aspect of it. I will ask you guys some question on Slack and expect each one of you to come up with your own answers to it by Googling, by doing something, and you learn from what others are posting. That's the social discovery aspect of it. So take these three things very seriously. And lastly, if you do the project, it is group learning. You learn together with groups. You form your study group. I would say that steady social discovery and study groups are the secrets that will really help you become good at this subject. So early on, form your team, form your group. keep each other motivated. There's a sufficiently large class. Form your group of people with whom you would like to sit together. Now, these are pandemic times. So support vectors unfortunately stays shut down during the daytime. And we don't have at this moment the resources to keep it open all the time. But there was a time, if you notice, all around you are conference rooms. There are about 10 conference rooms here. And it's a pretty, you could come and sit here and form, but at least while on Saturdays, you're welcome to uh, take all the extra time, get into the conference rooms, discussion rooms, literally form your team. And when you form your team, you talk things together, study together, it really helps. You can do that in the library, you can do it at each other's homes, you can do it over Zoom. One way or the other, stay engaged. Right? In US, when I came, someone once told me that most of success is just showing up. It took me a while to understand that thing, but the way I interpret it is that when you stay engaged, when you just show up, it keeps you going. You keep learning, right? So please do that. So that is the mechanics of the course. We have 4 teaching assistants. I'm your instructor, the primary instructor. There are 4 teaching assistants in this course. One is Kyle Vizzy. She is in India. She has been sending you some of the emails. She is in the India time zone. So you look at your clock when you need help. If it sounds like India time zone time, late night, reach out to Kyle. You can reach out during the day also, but then she may respond when she wakes up. In US time zone, we have 3 teaching assistants. Kate is here. She is again very, very helpful. She will help you. She has been, and all of the teaching assistants have gone through the same workshops that you are going through. So look at yourself as future teaching assistants if you're interested. Remember, you learn a lot when you teach, right? Or you help others. You're welcome to be future teaching assistants. It's a community learning environment. And Kate is here. Harini is another teaching assistant. She's also in the California time zone. She is local to Bay Area also. And there is Dennis Shen, who is also a local. Dennis, are you here today? Dennis is not. So there are 3 more teaching assistants in the California time zone. And one advice that I would do is, as part of being engaged, help each other. Right? So besides that, form a learning community. We all learn together. Right? And this is a journey. Every time I have been teaching machine learning formally, or some form, I've been, 30 years of teaching various subjects. There is not a time that I've taught a batch in which I have genuinely not felt that I've learned something from it. Right? Every time I teach something, I learn more about it. The subject is infinite. And the more attention you pay, the more you learn from it. And so let us all form a learning community. This is how we are. We are engaged through Slack. You all have access to a phone number. Anytime there is distress, there's a machine learning emergency, we have a number here. I hope it looks simple. This is as simple as it can get. Any machine learning emergency, you can dial our version of 911, right? Learn AI, call Learn AI. You will reach us instantly. Are we together? Right? So please do reach us. You can reach us by email, right? You can reach us by Slack. You can reach us by phone. And of course, you can be here in person. You can set up appointments. Any one of you who would like to make appointments with me, you're welcome to. Also, if you want to make one-on-one appointments with the teaching assistants, I strongly advise you to do that. If you need one-on-one help, we are very willing to help you here. Guys, everyone here, the teaching assistants, they are doing it out of a love for the subject. It's not, in fact, this place is not this entire place is not run as a commercial money-making place. We are all here because we love this subject and we like to share our knowledge for the subject. Right? All of us here are for that reason. So, and it's a to the extent that we are here as a community to learn and help others learn, please participate, take our help. We are here to help you. Right? It's not a commercial place that says, unless you make an appointment 2 weeks in advance, we won't talk to you. Right? You can reach us anytime you want, 24 hours. The more you will find, and the batches before you have found, I hope you would agree, those of you who are taken our previous workshops, that we have never been unresponsive. We are very responsive. We act, we talk, we reach out to you immediately. So, folks, at the end of it, you put a step of effort, and we would like to put a mile of effort from our side to take you forward. Right? Let's come together and let's learn. So, with those preliminary works, that's all I have about the structure of this course. Any questions before I start?